Hello students, welcome to another lecture on first year physics. Students, today we are going to start mechanics in general and kinematics in particular. So mechanics is that branch of physics which deal with the study of motion. As we know that in universe we are occupied with different kind of motion. So from an electron and from subatomic particle to huge galaxies, everything is in constant motion. So that's why it's very important to study motion. Okay, now in order to understand motion and different parameters associated with motion, so let us start our discussion from displacement. Okay, normally while if an object is in motion, so it is going to cover some kind of length, right? So let us say that we are having a point A and an object start moving from this point, and after some time it reach another point B, and then over here it reaches another point C, right? So from C finally it reaches point D. Now, as you can see that during the course of motion, it has gone through different points, and the distance which it has covered in order to reach D is followed by two other points B and C. Now, the object can reach from A to D directly following this path, and this path will be the shortest path, right? It can also take any other path. Let's say that, so this is, let's say, path 1, this is path 2, and this is path 3. Okay, now as we can see that from all these three different paths, the second path is the least or the shortest distance between these 2 points. So displacement is the distance which is actually being covered between 2 points, but it has to be the shortest one, right? So we can define displacement as the shortest distance between 2 points. Okay, so when the distance will be the shortest one, so automatically it will be along a straight direction or a single direction. So that kind of distance will be directed distance, right? So we can say that a displacement is actually a directed distance, and due to this sense of direction, we can call displacement as a vector physical quantity. So it is a directed distance, right? So if I am going to represent that kind of directed distance by AD, so we have to place an arrow above it because it is a vector quantity. Okay, in Cartesian coordinate system, let's say this is my x-axis, this is my y-axis. Let's say that an object is moving from point A to point B. So here it has two coordinates. So it has a coordinate along x-axis, let's call it x1, and similarly a coordinate along y-axis, y1. Similarly over here it has coordinate along y-axis, let's call that as y2. Similarly along x-axis that will be x2, right? So in order to find the directed distance between two such points on a Cartesian coordinate system, so what we are going to do is we have to find the difference between these two coordinates along x-axis and y-axis, right? So the distance over here, the displacement d would be del x plus del y, or simply you can say that del x dot comma del y, right? So here del x is x2 minus x1 and del y is y2 minus yn. So this delta operator, it is representing the difference, and in order to find the difference, what we are going to do is we have to subtract the final value from the initial value, or in this case when you are going to subtract y1 from y2, so we are going to get a positive value along y-axis, similarly a positive value along x-axis. So if an object is totally moving along x-axis, let's say that this is the initial point and this is the final point, right? So an object is actually moving along x-axis. So at that time, in order to find its displacement, right? So what we are going to do is we have to, at that time, we have to simply subtract x2 from x1 from x2. So let's say that it is measured in meter, right? So thus we can find the displacement. As it is the displacement, so we have to put an arrow. Okay, so that's how we can find the displacement on a Cartesian coordinate system, right? And even we can, find the displacement in three-dimensional space. So if an object is moving along that direction in space, so we have to find the coordinate along x, y, and z axis, and we have to find the difference between such two coordinates, right? Okay. We are going to define another parameter related with mechanics, that is what we call velocity. As we are familiar with speed because we encounter it in our daily life, right? So normally if you are driving a kind of car, right, so mostly we will be concerned with the speed of the car. But what is velocity? It is the same as speed, but it gives us a detailed information, right? And how we are going to define it? So for that, let us say that an object which is moving in any particular direction, and if that object is covering some sort of displacement with respect to time, obviously, if it is moving, so with passage of time it is going to cover displacement, right? So if it is changing its displacement vector with time, then at that time we can say that the object is actually moving in a specific direction and having certain velocity. So we can define velocity as the rate of change of displacement. So it is the rate of change of displacement. From your elementary class, you know that we can define speed as the rate of change of distance, right? So unlike speed, it gives us a detailed information in a sense that it also tells us that in which direction the object is moving. So the direction is involved, right? In this case, we are also interested in the direction. So it is giving us an information about the direction of motion as well. What does it mean? It means that velocity is a vector quantity and speed on the other hand is a scalar quantity. So we can represent velocity by letter V, and this velocity will be equal to the change. Rate of change means the time is involved, right? With respect to time, we are going to find the change in displacement. So we can write that for simplicity, I am going to represent displacement by x. Delta x represent the change in displacement. Our delta t, it represents the change in time, right? So the rate of change of displacement is actually what we called velocity. So if I am going to draw the displacement time graph, so let us say that this is the time in second and this is the displacement in meter, right? We can even represent displacement by d, right? So for simplicity, I'm using x. Okay. Now, if an object is moving, let's say from origin to certain point, okay, and let's say that we want to find its velocity between point A and B, then how we are going to find its velocity? So it is the displacement time graph, right? So it is the displacement time graph. So from displacement time graph, we can extract enough data in order to calculate the velocity, right? So over here at point A, it is corresponding to some value for displacement, and let's call that x1. Similarly, the final point corresponds to some other value of displacement, and let's call that as x2. Similarly, over here, when the object was at point A, let's say that the time it has taken is t1, and after reaching point B, the time passed is, let's say, t2, right? Now, in order to find the velocity, So from here you can see we have to find the change in displacement divided by change in time. So the change in displacement will be obviously x2 minus x1, right? So it will give us this much displacement. So this is what we called del x. Okay, so x2 minus x1 as the displacements are vector quantities, right? So this will give us this portion of the graph, and it is what we call the rise, right? In order to find del t, and this will be the change in time. So what we have to do is we have to subtract t1 from t2. So this will give us the run. Okay, so divide by t2 minus t1. So when we are going to divide the change in displacement or change in time, so over here it is rise over run. So for any rise over run, the result will be the slope of that kind of graph, right? So thus we can find the velocity, and here actually we are going to find the velocity between two different points, right? So we don't have any detailed information about the motion, so it gives us an overall overview about velocity. So we can call this as average velocity, v average, right? So this average velocity will be delta x times delta t, and we have found delta x as x2 minus x1 over t2 minus t1. If the object has started at time t is equal to 0, right, at that time automatically it will be transformed into t2 or simply t. Okay, so that's how we are going to find the velocity. Now what if we want to some detailed information about the motion of an object? If we are going to find the detailed information, so for that what we need to do is we need to introduce instantaneous velocity, because that we are interested in order to find the velocity of an object at any particular instant, right? So if someone asks you that what will be the velocity at this particular point, and let's call this as c, right? Then what we have to do is we have to shrink that time interval, and we have to decrease the time interval so that ultimately we will reach this point. So the slope at this point, the tangent at this point will give us the velocity, and that velocity at any particular instant is what we call instantaneous velocity. So for that what we are going to do is we have to decrease the time interval, and how much we are going to decrease, so that the time almost approaches to 0, right? So for that small interval we are going to find the velocity at any particular instant, right? So obviously an instant will be that kind of event which lasts for very microsecond time, right? So for that the instantaneous velocity, that's how we are going to represent instantaneous velocity. What we are going to do is we have to put the time limits del t approaches to 0. So we have to shrink the time interval, and how much we are going to shrink it, such that the change in time approaches to 0. So it will be very small, right? It will not be equal to 0 obviously, but the time interval has to be very small so that we can reach any particular instant. Again, the formula is it will remain the same, del x over del t. Now from calculus, when we are going to introduce that kind of limit, then this expression can be written in terms of differential change in displacement over differential change in time. This differential is nothing but the change in displacement and the change in time, but this change is very small. So for micro level change we can use the differential notation, and whenever you are having this limit you can simply replace the delta operator with differential operator, right? Okay, so that's how we are going to find the velocity at any particular instant, because we are going to shrink these 2 times limits. So when we are going to shrink it, obviously at this point the time limit will be very tiny. So let's say this is delta t, it approaches to 0. So for that much small time the information will be of any particular instant, right? So that's how we are going to find instantaneous velocity. Okay, and the previous one was average velocity. If an object, this graph here, it shows that the displacement covered is actually uniform in time. So if an object is going to cover equal displacement in equal interval of time, so such an object will be having uniform or constant velocity, because it doesn't matter if you consider the velocity between these 2 points, or if you consider the velocity between let's say this is D, the point D, between D and B. So you are going to get the same result, because obviously if as you can see the graph is straight, so after having different limit, you are going to increase the displacement, but at the same time the time interval is also going to increase in the same manner, right? So for equal displacement covered in equal interval of time, the velocity will be constant velocity, or what we call uniform velocity. But on the other hand, let me draw another graph. Displacement x in meter and the time is in second, right? Let us say that an object is moving, and this is how the object is going to cover displacement. So you can see from point, let's call this O, and let's call this as A. So from point O and A, the time interval or the change in time is that much. But what about the change in displacement? The change in displacement is small. It is not that much large, right? On the other hand, if we consider another interval between point A and point B, we can see that this is, so this was the time interval for the first two intervals, and here this is the time interval, and it is somehow small. Now delta t is small, right? But what about the change in displacement? So you can see the change in displacement is now large. So in small time interval, very large magnitude of displacement is being covered. So here greater value divided by smaller value gives us greater value, right? So the velocity is not the same. Throughout this journey, it is going to change. So such a velocity is what we call variable velocity. And in the next topic, we are going to cover that how we can find that kind of variable velocity, right? And we use a different terminology in order to represent variable velocity, and that is what we call acceleration. So far we discussed that velocity is the rate of change of displacement, and from displacement time graph we can find velocity, right? And for that we have to find the slope of the graph, and we need to find the change along the the y component, and along the x component. Okay, over here obviously along x-axis we have represented time, and along y-axis we have represented displacement, but displacement is represented with the symbol x. Okay, do not confuse this with the usual x-axis of Cartesian coordinate system. Okay, so students, if an object is not going to cover equal displacement in equal interval of time, then the velocity will not remain constant. So as the velocity is changing, so that kind of variable velocity is what we call acceleration. If any one of you drive a car, then you must be familiar with accelerator. So this accelerator, it is used in order to speed up or in order to slow down, right, the vehicle. So from this acceleration, we have adopted the word accelerator, right? Because if you are going to place your feet on the accelerator, the velocity or the speed of that kind of vehicle is going to increase. It is going to change. It is not going to remain constant. Okay, so acceleration can be defined as the rate of change of velocity. So if the velocity is changing, at that time we can introduce another term, that is what we call acceleration, right? This acceleration, it is also a vector quantity, because we are interested in the change in velocity. As velocity is a vector, so the change in velocity will also be a vector quantity, right? So this change in velocity change in velocity, it can be either due to change in magnitude, right, or change in direction. So if the magnitude alone is going to change, we can have acceleration, or even if the direction alone is going to change, we can have acceleration. And even if both magnitude and direction during a motion, if they are going to change, at that time we will be also having an acceleration. So we are going to discuss these cases in our later lecture videos. Right now, we are interested in acceleration. It is represented with small letter a and an arrow because it is a vector quantity. And here, as from the definition, we know that it is the rate of change of velocity with respect to time. If we are going to find the change in velocity and then we divide that change, our change in time, we are going to get acceleration. Okay. Now, in order to understand acceleration, we are going to draw velocity time graph. So shortly we can write VT graph. Okay, let us represent velocity along x-axis, and let's say that we are going to measure in meter per second, and the time along velocity along y-axis and time along x-axis, and this time is in second, right? Okay, now an object is moving such that its velocity is going to change. So you can see if the origin corresponds to 0 meter per second velocity, then after some time it is going to gain velocity, and with the passage of time the velocity is going to increase. If time goes on, so you can see from the graph the velocity is going to increase, right? So we are having a kind of variable velocity, and thus we can introduce acceleration, and we can extract enough data in order to calculate acceleration from this graph. So let us take 2 points, right? And let's say that again this is point A, and here we are having another point B. So we are interested in finding the acceleration of an object between such 2 points. Now what we have to do, obviously this point corresponds to any value. Let's call that as V1, right? So it will be having any value of velocity while when the time passes t1. Similarly, the object at point B, it will be having velocity that we call v2, and the time it corresponds is t2. Okay, so again what we have to do is we have to find the change in velocity, that is this much value, right? And then we have to find the change in time, and that change in time will be this much, delta t. And del v, from our previous discussion, we know that the final value minus initial value, right, divide by t2 minus t1. So thus we can find the acceleration between such 2 points. Again, this will be the change in velocity. You can see this will be the change in velocity, and this will be the change in time. This will be the change in velocity. So rise over run is again going to give us the acceleration in case of velocity time graph. Okay, and here you can see it is the slope of this graph, right? Whenever you are going to divide rise over run, then you are going to get the slope. Okay, what about its direction? So its direction will be the same as the direction of the velocity, right? Okay, so now if again we are going to find the acceleration at any particular instant, if we want detailed information, then we have to minimize the time interval so that the change in time approaches to 0. So for that much small time interval, the information will be of any particular instant, and that kind of acceleration will be known as instantaneous acceleration, the acceleration at any particular instant. So what we are going to do is we have to simply shrink the interval, the time interval, right, so that the duration will become very tiny, very small. And for that much small duration we can use the idea of instant, right? So that will be actually the acceleration for any particular instant. So for instantaneous, so this is what we call average acceleration. It gives us an overall information about acceleration between these 2 points, right? Throughout the journey what will be the most expected value for acceleration between these 2 points, right? So this is actually the average value. Okay, now let's call this average, and it is del v over del t. Now what about instantaneous? So for instantaneous, we have to write ins, right, an arrow. What we have to do is we have to place limits del t approaches to 0. So for such limits, the change in velocity over change in time gives us the acceleration at any particular instant. So again, that much small change can be replaced by differential operator dv over dt. So again, these differential operator, they are going to give us the change in velocity and the change in time, but very small change, right? Okay. Now the acceleration can be positive, it can be negative, depending upon the value of change in velocity. If the velocity is going to increase with the passage of time, then obviously the final value will be greater than the initial value, right? So at that time we are going to get as a whole positive result over here. So that kind of acceleration is what we call positive acceleration. Okay, on the other hand, if an object is moving and suddenly, let's take an example of a car. So while moving, if suddenly you apply brake, so it is going to slow down and eventually the car is going to stop, right? So over here, the velocity is actually decreasing, right? So the final value for such a case will be obviously less than the initial value. So if it is less than the initial value, so overall we are going to get negative value for acceleration. So such an acceleration is called deceleration, or what we call a retardation, right? So retardation is an acceleration, or what we call a negative acceleration, and in which the magnitude of velocity is going to decrease. So on the other hand, if the magnitude of velocity is going to increase, we call such an acceleration as simply acceleration, right? So over here, this graph shows a positive acceleration. Okay. On the other hand, let us say that we are having a graph, velocity time graph in meter per second and time in second. So if an object moves from here, point, let's call this O and point A, then it goes to point B, and then it goes to point C, right? Now, from this graph, you can see that between point O to A, the velocity is going to increase. So we are having positive value for acceleration. Over here, the velocity is almost constant. So if the velocity is not going to change, so we are not having an acceleration. So we are going to get 0 value for acceleration. And over here, after point B, the velocity is going to decrease. So the final value of velocity will be less than that of initial value for this particular interval between point B and point C. So here we are having negative acceleration, right? So the negative value of acceleration. Okay. Right. So that's how we are going to find acceleration using velocity time graph. So what will be the unit for acceleration? Is the unit for velocity as it is the ratio between displacement over time. So displacement is measured in meter, time in second. So meter per second is the unit for velocity, and the unit for acceleration, as you can see, that it is the ratio of velocity over time. So we know that the unit for velocity is meter per second and divided by time, so another second. So thus the unit for acceleration is meter times 2 seconds, so it becomes second square. So meter per second, the square will be the unit for acceleration, right?